Since C is really a low-level programming language, we can read and modify each bit in a value directly. This allows us to work with raw data, ignoring the type of a variable. In another video, we will see some examples of how modifying bits directly can be useful. In this video, we will focus on the tools, the operators that C gives us to manipulate bits. Let's first review the Boolean operations that are possible on a single bit. Recall that C represents false as the number 0 and true as 1. From your work with conditional statements, you have already seen that C provides a logical AND operator, 2 ampersands. C also provides a bitwise AND operator that is a single ampersand. For a single bit, the two operators look identical. But if you look at values other than 0 and 1, you'll see that they operate differently. Consider how numbers are represented in binary. The logical operator looks at the whole number and returns true if both arguments have a value other than 0. In contrast, the bitwise operator performs the AND operation on each pair of bits. Similarly, although you're already familiar with the logical OR, which is 2 vertical bars, C provides a bitwise OR, 1 bar. Like bitwise AND, bitwise OR works by performing the OR operation on each pair of bits. The bitwise exclusive OR operator is represented by a caret or hat symbol. It is 1 only if exactly one operand is 1. The result is 0 if both operands are 0 or both operands are 1. Exclusive OR is sometimes called conditional negation. If the first operand is 1, or true, then the result is the complement, the negation of the second operand. If the first operand is 0, or false, the result is the second operand without being negated. C also provides a bitwise negation or complement operator, the tilde. It takes a single value and flips every bit in the variable. 1s become 0s, and 0s become 1s. Be careful though, since it is a bitwise operator, while the bit 0 becomes the bit 1, the integer 0 will not become the integer 1. The C representation of an integer 0 has many bits, 32 of them, on my machine at least, and negating it would result in the number with 32 ones. Now that you know how each operator works, let's explore how to use them in a C program. The first problem is how to store bits in a variable. While the C language doesn't define non-decimal constants, GCC allows you to enter binary constants by prefacing the number with 0b. You can also use hexadecimal constants prefaced with 0x. Hex is convenient because the binary numbers are usually large, and it is pretty easy to translate from hexadecimal to binary, since one hexadecimal digit is 4 bits. The binary number we wrote first is equal to hex 1, 3. The first 4 bits are 1, and the last 4 bits are 2 plus 1, or 3. Let's look at a few of the operators using these values. As we mentioned earlier, the bitwise operators apply to each bit of the variable. So negating A will turn all 1s into 0s and all 0s into 1s. So the result is hex EC. Each bit in hex 1, 3 has been flipped. Let's look at the operators with 2 operands. We can line up the 2 operands like we would multi-digit arithmetic and apply the operator to each pair of bits. Let's check that. Can you predict the results of these statements? Now that we know how to perform the bitwise operations, we can start to use these operators in useful ways. In the next video, we will look at facilities for shifting bits.